Somewhere in Kent, England, stands one of the oldest surviving woodlands in the country, a green cathedral of oak, hornbeam, and sweet chestnut that has stood, in some form, since before the Roman legions ever set foot on British soil. To a visitor wandering beneath its canopy on a summer afternoon, the woods look like the very picture of ecological health. The trees are old, the leaves are thick, the green stretches unbroken toward the horizon. It looks, in every obvious sense, alive. But look closer, and the picture starts to fracture. Wildflowers that should carpet the forest floor in spring are rare here. Butterflies that once thrived in this part of Kent have quietly vanished from the record books. Birdsong, the kind that should fill an ancient wood from dawn until dusk, has thinned into something almost apologetic. Beneath a canopy that has never looked greener, biodiversity has been slipping away for decades, and almost no one noticed, because nothing about the decline looked like a crisis. It looked like nature, undisturbed, doing exactly what nature does. That was the trap. How can a forest look healthier than ever while dying from the inside? Nobody could yet explain why. But in July 2022, something happened here that would force the question into the open, and the answer would not look anything like a rescue. England released 4 giant animals into this struggling woodland, not to protect it from a distance, to let them loose inside it. And within weeks, those animals would do things that looked, to almost everyone watching, like exactly the wrong move to make in a forest already in trouble. 3 female European bison stepped out of transport crates and into West Blean that July, with a bull to follow later, to establish a breeding herd. It marked the first time wild bison had walked free in Britain in roughly 6,000 years, since the species vanished from the British Isles at the close of the last ice age, cut off from the mainland herds when rising seas severed the land bridge for good. The reaction was immediate, and it was not what the project's supporters had hoped for. Within days of release, the herd had already found the oldest, most established trees in their enclosure and gone to work on them, as if drawn deliberately to the parts of the forest everyone assumed needed protecting the most. The bison began stripping bark from mature, healthy trees, leaving pale wounds in the wood. They snapped branches under their own weight. They wallowed in muddy hollows until the vegetation around them lay flattened. Within weeks, visitors were photographing the damage and asking, sometimes furiously, whether the reintroduction had been a catastrophic mistake. Local newspapers picked up the story with a skeptical edge. Online, the images of broken trunks and torn bark spread faster than any explanation could catch up to them. Conservationists at Kent Wildlife Trust found themselves fielding a question they didn't yet have a fully satisfying answer for. Had England spent public money and international goodwill importing wild, cattle-sized animals just to finish off a forest that was already struggling? Even some scientists on the project privately admitted the optics were bad. Public meetings turned tense. A handful of regular walkers threatened to stop visiting altogether if the vandalism, as one letter to a local paper called it, wasn't brought under control. Park managers found themselves defending a project they still couldn't fully explain in a single sentence, not because the science was weak, but because the payoff hadn't arrived yet. And skepticism doesn't wait for data. Why would anyone deliberately release animals to damage a forest that was already dying? The answer wouldn't come from a press release. It would come from the ground, one strange discovery at a time, and it would begin with a ranger who had no idea, at first, that she was standing on the first piece of a much larger puzzle. Emma Carter had walked this stretch of woodland as senior ranger for 3 years, and for 3 years it had sounded the same. Quiet, almost too quiet, the hush of a forest that looked like a postcard and felt like a held breath. Then, on a routine patrol in the spring of 2023, the silence broke. Insects hummed somewhere in the undergrowth. A woodpecker drummed against dead timber. Somewhere close by, something large had recently passed through, leaving a young oak stripped bare and a scatter of hoofprints pressed into churned soil. Emma crouched beside a mound of dung crawling with beetles and felt a strange, unscientific chill. Nothing about this made sense. The forest she had walked 100 times had begun, almost overnight, to feel like a different forest entirely. Over the following weeks, she started keeping a notebook, then a spreadsheet. Fresh hoofprints, deep and cloven, appeared in mud where no path existed before. Piles of dung sat steaming in small clearings, and within days those piles were thick with insects she hadn't seen in this section of woodland in years. Sunlight, actual direct sunlight, was reaching patches of forest floor that had been in permanent shadow for as long as anyone could remember. None of it fit the story she'd been told to expect. The bison were supposed to be a disruption the forest would have to endure. Instead, everywhere they went, something seemed to be waking up behind them. But that wasn't the strangest part. The strangest part was what happened when she reported it. The ecological monitoring team at Kent Wildlife Trust didn't take Emma's field notes as proof of anything. Good science rarely accepts the first tidy explanation. And bison arrive, insects arrive, therefore bison caused it, was about as tidy as explanations get. Their first working theory, through the winter of 2022 into early 2023, was cautious. Perhaps it was seasonal. An unusually wet autumn might have triggered a natural insect pulse that had nothing to do with the herd at all. The team set up untouched control plots to test the idea properly. The results didn't fit. Insect abundance in the bison enclosure kept rising. In the control plots nearby, it didn't. Whatever was happening, it was tracking the animals, not the weather. So they revised the theory again. Maybe it was simpler than anyone was giving it credit for. The bison were just fertilizing the ground, the way any large grazer does, producing a short-lived nutrient bloom that would fade once the novelty wore off. That didn't fit either. When the team returned the following spring, expecting the bloom to have faded, they found the opposite. There was a third theory, briefly considered and just as quickly abandoned, that the changes had nothing to do with the bison at all, and everything to do with reduced foot traffic, since parts of the enclosure were now off-limits to walkers. Fewer people, the reasoning went, might simply mean less trampling and more room for wildlife to recover on its own. But the compartments with the least human access weren't the ones showing the strongest recovery. The compartments the bison used most heavily were. Isolation wasn't the driver. Whatever the animals were doing while no one was watching, that was the driver. What happened next confused everyone. Deadwood specialist beetles, insects that depend entirely on rotting timber and had been essentially absent from this section of the reserve, were now turning up in survey traps in real numbers. Weeks after that, fungi began colonizing broken and stripped timber in visible flushes. Then woodpeckers, drawn by the beetle activity inside the dead wood. Then wildflowers, blooming in clearings that had been too shaded to support them a year earlier. Then a measurable uptick in bird diversity across the bison-occupied compartments compared to the untouched control areas. Each discovery answered one question and immediately opened another. This wasn't a nutrient bump. A nutrient bump fades. This was building. By the second survey season, the team had assembled a timeline none of them had expected to write. First, the bark stripping. Then, within weeks, the first fungal colonies on the dead wood it left behind. Within a few months, the beetle counts. Within the year, the woodpeckers, then the wildflowers, then the wider bird recovery. Laid end to end, the data didn't look like scattered good news. It looked like a chain, each link pulling the next one into place. Something was moving through the forest that none of the individual data points could fully explain. A pattern the team could see taking shape but not yet name. For most of the 20th century, British and European forestry treated dead wood as waste, cleared away for tidiness, timber value, fire risk. It looked like responsible stewardship. It was, in fact, quietly starving the forest of one of its richest habitats. A single fallen oak, left to rot rather than removed, can eventually support hundreds of species of fungi, invertebrates, mosses, and lichens across the decades it takes to fully decompose. Strip that dead wood away, generation after generation, and you don't get a healthier forest. You get a tidier one with fewer species able to complete their life cycles inside it. The bison, the team began to realize, hadn't been brought in because they were rare and needed saving, though they are, in fact, a genuine conservation success story, hunted to extinction in the wild in the 1920s and bred back from a few dozen captive survivors. They were brought in because of what their bodies do to a landscape without any deliberate effort at all. Every broken branch became a foothold for fungi. Every patch of stripped bark, though it sometimes killed the tree, created standing deadwood that would host insect larvae for years. Every wallow became a temporary wetland, then dried into bare ground where light-loving plants finally had a chance to root. Every insect boom fed a bird boom. Every gap in the canopy let in enough light for pollinators to follow. The bison were not the ones restoring the forest. Something else was. Something that had been missing from this landscape for so long that no living scientist had ever seen it operate here firsthand. The bison had simply switched it back on. But if that was true, a bigger question followed close behind it. If a forest needs this kind of disturbance to stay alive, why did it stop happening in the first place? What vanished from British woodlands, and when? The answer reaches back much further than Kent. For roughly 1,000 years, English and wider European forest management pursued an ideal of order, tidy woods, uniform canopies, controlled growth, an aesthetic of health that prized stillness over the messy churn of a genuinely functioning ecosystem. Large native herbivores, bison, wild boar, elk, were hunted out of most of the continent centuries ago, their disturbance-driven habitats slowly replaced by managed plantations and closed canopy reserves designed to look untouched. The unintended consequence: playing out silently across generations, was a landscape that had lost the very mechanisms that once generated its richness. Britain alone is estimated to have shed significant woodland biodiversity value over the past century, with conservation bodies pricing the cumulative cost of degraded ecosystem function, lost pollination, reduced water filtration, diminished carbon storage, at over £350 million annually across the country's ancient woodlands. Set that against the Kent Bison project's £1.2 million in setup and ongoing cost, an investment already credited with measurable gains in insect abundance, plant diversity, and visitor tourism within its first 2 years, and the comparison stops looking like charity. It starts looking like extraordinarily cheap infrastructure repair. A government can spend enormous sums, often exceeding £12,000 per hectare, manually coppicing and clearing a woodland to mimic natural disturbance. 4 bison do the same job for free, indefinitely, with no maintenance contract at all. The story kept widening the longer the team followed it. One fenced reserve in Kent connected to a continental pattern, bison already reintroduced to Poland's Białowieża, to the Netherlands, to Romania's southern Carpathians, each project testing the same hypothesis in a different national context. It connected to a global conversation about rewilding, standing alongside wolves in Yellowstone, beavers across Britain and Europe, elephants reshaping African savannas. Different species, same underlying discovery. Some animals aren't simply wildlife to be protected. They are the machinery that keeps an ecosystem running. None of this unfolded without friction. Landowners near West Blean voiced early concern about bison escaping onto neighboring farmland, and the reserve's managers spent months reinforcing fence lines to address it. Walkers accustomed to open access had to adjust to new restricted routes, and some never fully forgave the inconvenience. The skepticism didn't vanish the moment the data started looking promising either. Even a full year into the monitoring program, some local voices remained unconvinced that a project built on visible tree damage could really be called a success, arguing that a handful of encouraging beetle counts didn't yet justify the scale of the disruption. Rangers like Emma had to learn, almost from scratch, how to manage a species Britain hadn't handled in the wild for longer than recorded history stretches back, developing new protocols for public safety, animal welfare, and herd movement essentially from first principles. Yet tourism operators found something unexpected in the disruption. Visitor numbers climbed as word spread of Britain's first wild bison in 6 millennia, bringing a modest but welcome boost of over £60,000 in local economic footprint within the first 18 months, to nearby villages, cafes, and guided tours that had struggled through years of declining rural footfall. By late 2024, the picture emerging from West Blean had grown more compelling, though far from complete. Insect diversity kept trending upward. Deadwood volume, long recognized as one of the single best predictors of woodland biodiversity, had increased measurably wherever the herd spent the most time. Plant species not recorded here in years reappeared in the new canopy gaps. But the scientists leading the monitoring program resist declaring victory in every published update. Ecological recovery on this scale isn't measured in months or even a few years. It's measured across decades, sometimes generations, as soil chemistry shifts and successive waves of species colonize newly available habitat. The herd is still small, still fenced, still far from the free-ranging populations that once shaped Ice Age Europe. Whether the approach can scale to other struggling woodlands, Whether the public will keep embracing animals that visibly damage trees in the name of long-term health, whether other lost ecosystem engineers could be brought back to do this elsewhere, none of it is settled yet. What is settled, at least for now, is the shape of the question itself. Nobody at West Bleen is still asking whether damage and recovery can be the same event. The evidence, gathered slowly and against considerable early doubt, has answered that much. What remains open is how far the answer travels beyond this one fenced reserve in Kent. Emma Carter still walks those same transects today, and the forest she moves through no longer sounds like the one she first patrolled. There is more birdsong now, more insect hum, more genuine unpredictability in what she'll find around the next bend. None of it looks tidy. None of it looks like the manicured green woodland that used to reassure visitors that everything here was fine, and that, in the end, is the answer to the question this documentary opened with. A forest can look alive while dying, because health was never about how green the canopy looks from below. It was about whether the processes that built that forest in the first place are still running underneath it. The breaking and the rotting and the regrowing. The parts that look like damage but are actually maintenance. The bison didn't heal this forest. They didn't need to. They simply gave it back something it had been waiting 6,000 years to remember how to do for itself. The experiment is still being written. One broken branch, one fresh wallow, one returning species at a time. And somewhere out in that Kentish woodland right now, the herd is almost certainly doing something that looks, at first glance, like damage. If this story of a forest quietly remembering how to be wild has stayed with you, subscribe to our channel, because West Bleen is only the beginning of a much bigger story unfolding across the world's forests, and we'll be there, following it, wherever it leads next.